Despite the fact that today's automobiles pollute less than could have been imagined even a few short years ago, they must get cleaner still. One possible method of reducing emissions is to use fuels that burn cleaner than gasoline. But do such fuels exist? Believe it or not, cleaner fuels do exist, and Chrysler Corporation is in the forefront of developing vehicles to run on them. Welcome to Mastertech's fifth release for 1993. In this program, we'll look at some vehicles that run on alternative fuels. First, we'll look at the flexible fuel Spirit and Acclaim models. We'll discuss their fuel and cover some service tips. Next, we'll take a look at the Ram van and Wagon that are powered by compressed natural gas. Naturally, we'll also investigate some service items with these vehicles. And lastly, we'll take a brief informational look at the electrically powered Caravan and Voyager models. So let's get started with the flexible fuel Spirit and Acclaim. This car may look like any other Spirit or Acclaim that you've seen, but if you get closer, you'll notice decals on the front fender that identify the car as a flexible fuel or flex fuel vehicle. There are a couple more methods of identification that aren't as apparent as the decals. On flex fuel vehicles, the 8th letter of the vehicle identification number will be the letter V. Also, some components will have green labels to inform you that these components are specifically designed for use with the methanol that fuels these vehicles. Let's find an example under the hood. Here you can see the green labeling on the oil filler cap that tells you to use only oil that is specifically formulated for use in a methanol-powered vehicle. This is an important point. You can't use just any oil. Methanol has a greater tendency than gasoline to wash the lubricating film off the cylinder walls. This 10W30 oil has special additives to prevent that from happening, and it's available in your dealerships. Only oil that has been specially formulated for use with methanol gasoline blends should be used in these flex fuel vehicles. The oil filters, however, are identical to those used on regular Spirit and Acclaim models. Even with this special oil, the normal oil change interval for flex fuel vehicles is every 5,000 miles instead of the 7,500 miles for the gasoline-powered vehicles. While the hood is up, let's take a look at some more features of the flex fuel vehicles. The Spirit and Acclaim flex fuel vehicles use a modified corporate 2.5-liter engine with a throttle body similar to the one on the 2.5-liter Turbo 1 engine. The air cleaner ducting is unique, but the air filter element itself is from the Turbo 1 engine. As for everyday operation, driving the vehicle on methanol as opposed to 100% gasoline offers no noticeable performance difference, except that methanol actually adds a little more horsepower. When using the maximum amount of methanol allowed in the fuel mixture, known as M85, horsepower is 106 and torque is 145 pound-feet. This compares to 101 horsepower and 141 pound-feet of torque when using 100% gasoline. However, because methanol has a lower energy content than gasoline, with M85, the EPA estimated fuel mileage is 13 miles per gallon in the city and 15 on the highway. This is considerably lower than the 21 in the city and 27 on the highway with 100% gasoline. But taking into consideration that M85 may be cheaper than gasoline, the price per mile may be about the same as premium gasoline. Well, now that you know a little bit about the vehicle, let's find out a little more about its fuel, methanol. What comes to your mind when you hear the word methanol? If you're like a lot of people, you probably said corn. That's ethanol, which is most commonly made from fermenting grains like corn. While methanol, or wood alcohol as it is sometimes called, can be made from such things as wood or even municipal waste, at the present, the most common and economical source is from natural gas, the same energy source used to cook meals and heat homes. Besides cost considerations, making methanol from natural gas has other advantages, one of which is that natural gas is abundant in North America, thereby reducing our dependence on foreign oil. Despite these advantages, the main reason for using methanol, as you no doubt know, is because of its lower emissions compared to gasoline. use of M85 can reduce harmful hydrocarbon emissions. You remember all that information we told you about hydrocarbons in the January Mastertech, right? How about that long section on reactive hydrocarbons? If you answered yes, then your memory is not as good as you thought it was, because we did not distinguish between reactive and non-reactive hydrocarbons. In the past, hydrocarbons were measured as one group, but when using methanol, it's useful to divide the HC emissions into the reactive and non-reactive groups. Reactive hydrocarbons are simply those that have a greater tendency to cause smog, and using methanol as a fuel produces less of these. You'll remember from the January program we said HC can combine with oxides of nitrogen in the presence of sunlight to produce smog and ozone. This is an example of reactive hydrocarbons. Reducing these reactive hydrocarbons and the smog they can produce is but one of the reasons Chrysler Corporation is concerned enough to build these alternatively fueled vehicles. The emissions from a methanol mixture may be less harmful to the environment than those from straight gasoline, but that should by no means lead you to believe that methanol is safer to handle. There are a few precautions that must be followed when working with methanol. Since these flex fuel vehicles look and operate almost identically to gasoline-powered cars, it's easy to forget that the fuels are quite different. First, you must wear methanol-resistant gloves and eye protection. Methanol can actually be absorbed through the skin from prolonged contact. At the very least, it can cause dry skin or an allergic reaction. The reaction can be more severe for some people. For instance, for someone taking medication for the treatment of alcoholism, getting methanol on their skin may cause them to feel ill. If your skin does come into contact with methanol, wash the area with soap and water as soon as possible, especially before you eat, drink, or smoke. Also, be sure to wash all clothes contaminated by methanol before wearing them again. Even breathing methanol vapors can cause headaches, dizziness, or unconsciousness, so be sure the work area is well ventilated. Also, be aware that methanol vapors can actually travel along the ground, and they're very flammable. As with gasoline-powered vehicles, you should never smoke while servicing a methanol-powered vehicle. It almost goes without saying that you should never drink methanol, since it can cause a serious injury like blindness. It can even cause death. I mention this because these cars look almost identical to non-flex fuel cars. And in an emergency situation, someone may attempt to start a fuel siphon with their mouth, not knowing the possible consequences of this act until it's too late. While these vehicles have a conical spring designed to prevent a siphon hose from being inserted, it's still a good idea to remind customers and dealership personnel never to attempt to siphon methanol by mouth. At this point, let's take a break and go to our first review question. What color is used on labels to identify unique flex fuel components? The answer is green, as you'll perhaps remember from the oil filler cap. Let's continue on with more about the methanol fuel used in these flex fuel vehicles. The flex fuel vehicles can use any mixture of gasoline and methanol up to 85% methanol and 15% gasoline. This 85% methanol is the M85 we mentioned earlier. If there were 100% gasoline in the tank, it would be called M0. There are a few reasons for using M85. First, without the 15% gasoline in the mixture, a flex fuel vehicle would have cold start problems. Increasing the amount of gasoline in the mixture will usually solve any cold start problems. Another reason for adding at least 15% gasoline to the mixture is safety. Methanol has no smell, and adding gasoline to the mixture identifies the mixture as fuel. The final reason for adding gasoline is also for safety. When methanol burns, its flame is invisible. Naturally, this can be dangerous. Gasoline is added so the flame can be seen. If you are faced with an M85 fire, it can be extinguished with common dry chemical, such as is contained in this dry chemical extinguisher. After all this talk about methanol, have you figured out the maximum percentage of gasoline that can be added to the mixture? You probably figured out from earlier comments that you can put in 100% gasoline. This is the great advantage to the flex fuel vehicles. You'll never get stranded if you run out of the methanol mixture. You can simply fill up at any gas station if methanol is not available. Being able to fill up with different methanol and gasoline mixtures is possible because of the methanol concentration sensor that's located near the fuel tank. This Chrysler patented device senses what the fuel mixture is and, along with the oxygen sensor, informs the powertrain control module so it can adjust the amount of fuel that the injectors spray. The methanol concentration sensor's coil measures an electrical property of the fuel known as its dielectric value. The dielectric value of gasoline is 2, and methanol's value is 33. Because the difference of these two values is so great, the sensor can estimate how much methanol is present by measuring the dielectric value of the fuel passing through it. The methanol concentration sensor is not the only component of the fuel system that's different from a strictly gasoline-powered vehicle. Let's begin with the fuel supply components. Because methanol is more corrosive to metal than gasoline, the fuel tank is made out of high-density polyethylene. As we mentioned, range is shorter with methanol, so the capacity is increased from 16 to 18 gallons. The fuel sending unit is also different. On this unit, the resistive strip that controls how much current reaches the fuel gauge is on the outside of the tank to protect it from the methanol. Gasoline-only vehicles have this strip inside the tank. The fuel gauge that the sending unit connects to is specially calibrated for the larger tank, despite the fact that it looks identical to the regular models. Again, back at the fuel tank, the fuel pump and the pressure relief and rollover valve are also specifically designed for methanol compatibility, as well as the fuel filler neck leading to the tank and its cap. Basically, everything that comes in contact with the methanol fuel and its evaporative emissions has been replaced with methanol-compatible components. Components such as the fuel lines, the fuel filter and housing, the fuel pressure regulator and its O-rings, the fuel rail, as well as the fuel injectors and their O-rings. The fuel injectors are not only nickel-plated internally for methanol compatibility, but they also allow greater flow capacity. This is necessary because, as we have mentioned, it takes more methanol to do the same job as gasoline. We said earlier that all fuel and evaporative emission system hoses and tubes have been replaced with methanol-compatible components. Naturally, this includes the purge solenoid. The purge solenoid and the canister are made out of methanol-resistant materials. The evap canister is larger to accommodate the increased amount of fumes generated. Because of the very wide pulse width of these flex fuel injectors when using methanol, it's possible that so much fuel is sprayed during cold conditions that the fuel can actually leak down into the crankcase. At warm temperature, this fuel becomes vapor and goes through the PCV valve. The PCV valve is from the 92 Turbo 1 system, but here there are nylon clamps at each joint to withstand the higher crankcase pressure that can be caused by this methanol evaporation. The only other change to the emission control system is that the catalytic converter contains different metals internally. As for the ignition system, these vehicles use the twin-lead distributor from the 2.5-liter Turbo 1 engine. Well, those are the fuel, emission, and ignition system components that are different from gasoline-only Spirit and Acclaim models. Some internal engine parts have also been changed. The cylinder block, head, and head gasket are cross-drilled like on the 2.5-liter Turbo 1 engine to promote better cooling in the area between the cylinders. The piston rings are chrome-faced because methanol attacks the materials used in conventional rings. The valve stem oil seals are also different. They're made out of a special material to resist the trace amounts of methanol in the oil. The intake valves are taken from the 2.5-liter Turbo 1 since they can better resist the high temperatures resulting from burning methanol mixtures. Well, that's it for different components. Not as bad as it sounds, was it? Really just material changes to familiar components and a few other components borrowed from the Turbo 1 engine. Diagnostics are just as familiar. In fact, diagnostics are practically identical. The only difference being that the check engine light can come on to inform the customer of a failed methanol concentration sensor. The sensors have been tested extensively and have lasted for up to 400,000 miles. But if one should fail, it will default to the last value. That is, it will tell the PCM to adjust the air-fuel mixture to fit whatever methanol and gasoline mixture it last sensed. This should cause no drivability problems so long as a completely different fuel mixture is not added after the sensor's failure. To check out if the sensor is working properly, use the scan tool or MDS to investigate. The display tells you the percentage of methanol in the tank and the voltage output of the sensor. The fault display would tell you if the sensor voltage was out of range. These are the only other diagnostic displays used on flex fuel vehicles that are different from their gasoline-only stablemates. If you received a fault message that indicated that the methanol concentration sensor had failed, replacing it is a very simple procedure. First, fuel system pressure must be released by attaching a hose to the fuel pressure test port and draining the fuel into an approved container. After the pressure is released and the vehicle raised, you need to disconnect the fuel lines at the sensor. These fittings are the quick connect type to make removal easier. Next, remove the electrical connector. And finally, remove the mounting nuts. Be careful when removing the old sensor because there will be some fuel left in it. After you have the old sensor off the bracket, putting the new one on is just the reverse of the removal. As you can see, there is very little that's different than the gasoline-only Spirit and Acclaim models. And all of the service information is even contained in the same manuals. The information we've covered will be useful in the future. For 1994, versions of the 3.3-liter Concorde, Intrepid, and Vision will be added to the flexible fuel lineup. Now let's test just how much of this information you have learned with our second review question. When having a cold start problem while using a methanol mixture as fuel, what will more than likely cure the problem? The answer is adding more gasoline to the mixture will cure the problem. Just like our flex fuel Spirit and Acclaim models, this Ram van doesn't look much different than a conventionally powered model. But this van is also different. You just have to look underneath it to see that. These fuel cylinders contain compressed natural gas, or CNG for short. Of course, just like the flex fuel vehicles, you don't have to climb underneath to find out it's different if you know what to look for. There are identification decals on the rear door of the van, inside the fuel filler door, and under the hood. Also, the 8th position of the vehicle identification number will be a letter T. Why choose the Ram van and Wagon to be powered by CNG? It's simple. They're popular fleet vehicles, and CNG vehicles are purchased mostly by fleet owners. Fleet operators, especially utility companies, already have central refueling points. Important because CNG fuel stations are not just everywhere. For these fleet operators, compressed natural gas is a very good fuel. First, it's very plentiful. As mentioned earlier, natural gas is abundant in North America. This ensures a safe supply that decreases our dependence on foreign oil. And of course, it's cleaner. In fact, it's the cleanest of all available fuels. With CNG, tailpipe carbon monoxide and hydrocarbons are reduced because no fuel enrichment is required. With gasoline, extra fuel must be provided because not all of the fuel vaporizes and burns. CNG is already in a gaseous state, ready to burn. CNG also eliminates evaporative hydrocarbon emissions. One of the reasons is that CNG uses a sealed fuel system so that no vapors can escape. An evaporative emissions system is not even needed. Just as with methanol, though, there are certain precautions that must be taken when working with compressed natural gas. First, always work in well-ventilated areas. CNG, if allowed to collect, can form a combustible mixture in enclosed high areas. The fuel system itself should never be modified. Also, never weld, paint, or undercoat any fuel system component. Certainly, you should never park the vehicle near excessive heat or flames, including paint ovens used to cure paint repairs. Never attempt to force open or tamper with the fuel fill receptacle. This could cause a sudden release of natural gas that is pressurized up to 3,000 pounds per square inch, increasing the risk of explosion or fire. Now that you've seen a little of the CNG Ram van, you may think it's completely different than a conventional vehicle. Actually, it's very similar. Unlike the flex fuel vehicles, the CNG Ram van and Wagon do not need a special oil. In fact, the maintenance schedules are identical to conventional vans. Naturally, there are some differences. These vehicles are not offered with rear air conditioning or a rear heater. And as we mentioned earlier, these vehicles have no evaporative emissions system. Performance and range of the CNG vehicles is also different than gasoline-powered vehicles. Currently, these vehicles have a range of 120 to 180 miles. The range is reduced because CNG has about 1/4 the energy density of gasoline. Fortunately, CNG can cost as little as half the equivalent amount of gasoline. Performance is also a little lower than that of gasoline-powered vehicles. Even though CNG has a higher octane rating, it displaces more air than gasoline, reducing the amount of air in the combustion chamber. This reduction in air means a 10 to 15% decrease in performance compared to a gasoline-powered Ram van. Since the fuel system in CNG vehicles is where all of the major differences lie, let's take a closer look at the major components and their locations. There are 3 fuel cylinders, 1 on the driver's side and 2 in the rear. All 3 are interconnected and are filled through the fuel fill receptacle. On the passenger side, the fuel passes through the main fuel shutoff valve and the fuel pressure regulator. The pressure regulator reduces the pressure from 3,000 psi to about 120 psi for use by the engine. Of these components, perhaps the most important is the main shutoff valve located inboard of the right frame rail in front of the rear wheel. When it's horizontal, the valve is open. When it's turned vertical, the valve is closed and the fuel cylinders are isolated from the rest of the fuel system, including the fuel fill tube and the tube to the engine. There are also individual shutoff valves on each of the 3 cylinders. Here we see the valves on the 2 rear cylinders. To turn them off, the valves must be turned fully clockwise. These valves are also equipped with relief devices that are designed to release excess pressure if the temperature rises above 217 degrees Fahrenheit. Once they release pressure, the valves must be replaced. The fuel fill receptacle is located on the driver's side behind the rear wheel. The receptacle contains an integral check valve to keep fuel from escaping. Another check valve is located in the fuel fill tube near the top of the left rear shock absorber. The 3rd fuel cylinder, located along the driver's side, is protected from the exhaust system by a heat shield. On this cylinder is the fuel gauge pressure sensor. This sensor converts the high pressure of the gas to an equivalent resistance of between 8 and 100 ohms. This signal operates the fuel gauge. As you can see, it's the same gauge as used on the gasoline-powered vans. In the engine compartment, the fuel rail is unique to this CNG system. This rail can be easily disassembled for replacement of the inlet blocks, connecting tubes, and O-rings. The fuel pressure regulator is not part of the fuel rail as it would be on a gasoline-powered vehicle. As we mentioned, the regulator is on the right side of the vehicle. The regulator contains another pressure relief valve that relieves low side pressure if it rises above 175 psi. The regulator also contains the fuel filter. The filter has no service interval. It only needs to be replaced if contamination is suspected. To warm the fuel after its expansion to low pressure, 2 rubber coolant lines carry engine coolant to the regulator. This prevents the regulator from icing up in cold weather. The remaining unique components provide inputs or outputs to the powertrain control module. Among the inputs, the fuel pressure sensor measures fuel pressure in the fuel rail. The PCM uses this sensor's signals to adjust injector pulse width. The lower the pressure, the wider the pulse width. The sensor is located on the fuel rail inlet block. Another sensor used by the PCM to adjust injector pulse width is the fuel temperature sensor. It's also located on the fuel rail inlet block and is the same part as a truck coolant temperature sensor. If this sensor tells the PCM that the fuel is cold, that means it's more dense and less fuel will be needed. As for the PCM outputs, normally closed low-pressure fuel shutoff solenoid allows fuel into the fuel rail only when the engine is running. When the engine is shut down, it blocks fuel from the fuel rail to prevent pressure bleed down in case of a leaky injector. The high-pressure fuel shutoff solenoid is mounted on the high-pressure side of the pressure regulator and is controlled by the PCM through the high-pressure fuel shutoff solenoid relay. This solenoid shuts off gas flow to the regulator when not energized. The TEVan's sequential multi-port fuel injection system uses 8 low-impedance fuel injectors that require high current. To supply this current, the PCM activates a special injector driver module. This module is located next to the PCM and contains special heat sinks to dissipate the heat energy generated when controlling the high current. The 5.2-liter CNG engine even has a few components specifically designed for use with compressed natural gas. The cylinder heads have valve seat inserts because CNG does not provide as much valve lubricant as unleaded gasoline. These inserts can be reground, but they are not replaceable. The exhaust valve stem seals are the same as the seals used on the gasoline 5.2-liter engine. In fact, they're also used for the CNG intake valve stem seals. Using these exhaust valve stem seals on the intake valves provides more oil for improved lubrication. For better durability, the intake valve stems are flash chrome plated. As you can see, even with the unique components, the CNG vans really are not much different than conventional gasoline-powered vehicles. Service issues aren't much different either, except when dealing with the fuel system. One item you should be aware of is the sound the fuel injectors make. Because there is no liquid passing through them to help muffle the sound, the CNG injectors are louder than gasoline injectors. This is mostly a concern with the 1993 models, since changes were made to make the 94 models quieter. However, even the 94 models will be louder than a gasoline-powered vehicle. Working on the fuel delivery system should not worry you if you do the procedures properly and read all of the cautions in the service manual. One such caution is to remember to purge the fuel tubes of fuel when servicing a CNG component. To do this, first check to see if the main shutoff valve is open. Now close the individual shutoff valves on all 3 fuel cylinders. Do you remember from earlier which way to turn them? You turn them fully clockwise to close them. With the fuel cylinders closed, start and run the engine until it runs out of fuel. When it runs out of fuel, try to restart it 3 times. Naturally, there is still fuel in the cylinders, but at this point, almost all of the fuel tubes have been purged. If you need to service the fuel fill receptacle or check valve, then slowly loosen the inlet side of the fuel fill tube at the check valve in front of the left rear shock absorber. By doing this, you will release the remaining gas, but be aware that it will be at about 25 psi. At this point, all the fuel tubes have been purged. Refer to the Compressed Natural Gas Ram Van Wagon Service Manual Supplement for more information on any of the procedures unique to these vehicles. As for diagnostic information, there are 4 fault messages that are exclusive to CNG vehicles. They are compressed natural gas temp sensor low, compressed natural gas temp sensor high, compressed natural gas pressure high, and compressed natural gas pressure low. The only other difference from the gasoline-powered vehicle diagnostics is that some of the diagnostic displays have been eliminated when they don't apply to the CNG system. Readouts such as fuel pump pressure. Of course, all of this information is contained in the 5.2-liter compressed natural gas powertrain diagnostic procedures manual. Now let's take a look at our next review question. When released, compressed natural gas does which? Travel along the ground or collect in high enclosed areas? The answer is that it collects in high enclosed areas. It's for that reason that you must have adequate ventilation when working on CNG vehicles. The last vehicle we're going to look at has even lower tailpipe emissions than CNG vehicles. In fact, it has none at all. That's because it's an electric van. Codenamed the TEVan, this vehicle is based on the Caravan Voyager minivan because of its popularity. The minivans also have a high, flat, strong floor that is ideal for storing the heavy battery pack and does so without taking up any interior space. This pack is made up of 30 6-volt batteries that will either be made of nickel-cadmium or nickel-iron. These batteries have a range of 80 miles per charge, twice the range of common lead-acid auto batteries. At home, the TEVan can be recharged in 8 hours through the charging plug on the front fender when using a 220-volt single-phase charging setup. With the Norvik Minute Charger, however, it can be accomplished in less than 1 hour. The DC motor is rated at 35 horsepower for continuous operation and 70 horsepower at peak loads, such as when accelerating. The TEVan has a special watering reservoir for the batteries, as well as electrically driven power steering pump and air conditioning compressor. The van's heater and defroster are also electric. At present, there are plans to build about 50 of these vehicles for sale to fleet owners. Currently, there are no plans for the TEVan to be dealer serviced. Well, let's take a look at our last review question. When using the Norvik Minute Charger, the TEVan can be recharged in how many hours? The answer is less than 1 hour. Well, that's it for this month's Mastertech. We've discussed the Flex Fuel Spirit and Acclaim, including cautions and warnings about handling their fuel, as well as some service information. We've also done the same for the compressed natural gas Ram van and Wagon. And finally, we've introduced you to the electrically powered TEVan. With the increasing numbers being produced, some of these alternative vehicles could soon be in your dealership if they aren't already. Why not be ready for them? So until next month, goodbye.
TSB 22-02-93 concerns all 1993 Concorde, Intrepid, and Vision models, as well as the new 1994 New Yorker and LHS. A few customers may complain about road noise or a harsh ride in these cars. Fortunately, there's a very simple adjustment you can make that is already being incorporated as a running change.
Then remove the upper half of the heater housing. You can now lift the evaporator out of the lower housing. Transfer the existing expansion valve onto the new evaporator with a new gasket. Also, transfer the evaporator sensor and place it in the same location. Use the valve spring compressor, special tool MD9987772A with adapter 6527 to compress the valve spring.
Affected 1990 models are those built from December 12, 1989 through January 12, 1990. On these vehicles, fuel vapors may vent to the atmosphere.
This is Leslie Rabb with you this time from the Mopar Parts Mile High Nationals at Bandimere Speedway in Denver, Colorado. 26,000 enthusiastic race fans gathered to watch the exciting final rounds of this event. In the top fuel dragster category, the final
you fix up one thing, something else breaks, you just sort of chase that weak link right through the system until it's not there anymore. The drivetrain has a brand new 6-speed Borg-Warner gearbox. We have an aluminum prop shaft, a Dana 307 rear axle, and Dana half shafts.
These flex fuel vehicles, or FFVs, can operate on a variety of mixtures of gasoline and methanol. Currently, the flex fuel approach is the most practical alternative for passenger cars. In this program, we'll examine what exactly a flex fuel vehicle is.
Hey, if you're not watching CDN, what are you watching?